Okay, now this problem continues. Now we have another person, Clara. She enters the same tennis competition as Tom of the previous question. Now let B be the number of matches Clara wins on any given day. So again, B is a discrete random variable because number of matches cannot be cannot take decimal values, right? So it is a discrete random variable. All right. Now the probability distribution for B is modeled. It's given in the table below. This table. Find the expected number of games that Clara wins. Okay. Expected number. Now the expected value or the expected number will be, see, expected value of B will be sigma x into P of x. Or in this case, our x is B, so it will be sigma B into probability of B. Yeah? Now, which is 0 into 0.05. B is this. Okay. The upper row gives B, and the lower row, bottom row gives P of B, probability of B. So sigma B times PB is 0 into 0.05 plus 1 into 0.01, sorry, 1 into 0.1 plus 2 into 0.35 plus 3 into 0.5. So that becomes, this is 0, 0 into 0.5 is 0, 1 into 0.1 is 0.1 plus 0.7, 3 into 0.5 is 1.5, that's 2.3. So the expected value, okay, or the expected number of games that Claire can win on any day is 2.3. My answer is 2.3. Okay. On the final day of the competition, Tom and Claire play their three matches. See, Tom's values were given in the previous question. Tom is playing three matches, Claire is playing three matches, and the matches are independent. Whether Tom wins or loses does not depend on whether Claire wins or loses, and vice versa. Okay. So the number of wins Tom and Claire obtain are then added to form a total of six. Correct. Find the probability that they win more than four matches combined. So put together, okay, number of wins is added together, okay, to form a total of six, right? So find the probability that they win more than four matches together. More than four. Okay, which means it can be five, it can be six, more than four. Now, since Tom and Claire are playing three matches each. See, sorry, Tom and Claire, each person is playing three matches. Tom, and Claire. Now, Tom can win 0, can win 1, 2, or 3. Again, Claire can win 0, 1, 2, or 3. And the results are independent. Even we want a total of 4 victories. Okay, both Tom and Claire together should post a total of 4 wins. So 0-0 is not possible. If Tom wins 0 and Claire wins 0, the total will be 0. Not possible. If Tom wins 1, Claire wins 1, total is 2. Again, not possible. But yeah, if Tom wins 2, Claire wins 3, again the total is 4. Not acceptable. We want a total greater than 4. Okay, and there are only two possibilities. Total can be 5 or total can be 6. The maximum total, okay, is 6. It cannot be more than 6. So, okay, the maximum total of the number of wins is 6. 3 plus 3 is 6. So, I have got Tom here, Tom and Claire. Now, Tom can win 2 matches, Claire can win 3 matches. So, total will be 5 matches. Fine, accepted. Tom can win 3 matches, Claire can win 3 matches. Total 6. Acceptable. Tom can win 3 matches, Claire can win 2 matches, total 5. Again acceptable. These are the three possibilities that are agreeable to us. Okay, that agree with the with the condition. So let's find the probability. Now the probability that Tom wins 2 is how much? Tom wins 2. We know from the previous table it is 0.4. The Tom can win 2 and Claire can win 3. Okay. Okay. The probability that Tom wins 2 is, I'll write the probabilities here in red. Tom wins 2, 0.4. Tom wins 3, 0.25. 0.25. Claire wins 3. hmm? Claire wins 3, that's given to us. No? Claire wins 3, the probability is 0.5. 0.5. 0.5. Claire wins 2, it is 0.35. Is it 0.35? 0.35. Am I right? 0.35. Okay. So, probability that Tom wins 2 and Claire wins 3 and. So it's multiplication. So 0.4 into 0.5. Probability that Tom wins 3 and Claire wins 3. So 0.25 multiplied by 0.5. And probability that Tom wins 3 and Claire wins 3 is this is 0.25, not 24. It's 0.25 into 0.35. Yeah. So how much is this? This will be 0.2. 0.4 into 0.5 is 0.2. So this will be 0.2. 0.25 into 0.5 is 0.125. And 0.25 into 0.35 is 0.0875. The total is 1.2, sorry, 0.2 plus 0.125 plus 0.0875, that's equal to 0.4125. Okay, I will repeat this part. See, uh, we want to find the probability that Tom and Claire together they post a total greater than four. They win more than four matches together. So that is possible if Tom wins two and Claire wins three. So 0.4 into 0.5, which is this, which is this. Or Tom wins three and Claire wins also wins three. That's 0.25 into 0.5. Remember it is and, so we multiply and. Tom wins 3 and Claire wins 2. So 0.25 into 0. I want to emphasize that we are saying and. Okay, so we are multiplying the respective probability. Now, how can they score 4? They can score 4. Either Tom wins two matches and Claire wins 3. Or Tom wins 3 and Claire wins 3. Or Tom wins 3 and Claire wins 2. So these are or. Okay? So we add. When it is or, we add. When it is and, we multiply. Yeah? When it is or, we add. When it is and, we multiply. So now we adding either this or this or this. These are the three possibilities. So we add and we get total 0.4125. So the probability that they score more than four, that they win more than four matches together is 0.4125. We can also, I can also explain this using a decision tree. See, Tom can win either two or three. Claire can, the possibility of Tom winning two is 0.4. Tom winning three, 0.25. Claire can win either two or three. Two or three. Now the probability of Claire winning two is 0.35. It's given in the table here. Is 0.35. Huh? Is 0.35. This is 0.5. Again 0.35. 0.5. Yeah. Now, if both win two matches, the score will be 4, which is not acceptable. We want more than 4. So, this we won't accept. This we won't accept. Right? Because the total will be 4, which is not acceptable. But here the total is 5. So, it is 0.4 into 0.5. Here the total is 5 and it is 0.4 into 0.5. Here again the total is 5. It is 0.25 into 0.35. See, and Tom wins 2 and Claire wins 3. So, and. So, we multiply. Tom wins 3 and Claire wins 2. Again, we multiply. Okay? And here, Tom wins 3 and Claire wins 3. So, we will multiply. So, 0.25 into 0.5. So, we get so when it is and, we multiply. Now, how can we get more than 4? We can get more than 4 if we take this route, or if we take this route, or if we take this route. Okay, so these are the only possibilities. Okay, the only possibilities are one or two or three or. So we add up all three. We get 0.4125. So the probability that they post a total greater than 4 is 0.4125. Okay. Now, the last part. Given that they win more than 4 matches combined, find the probability that Claire won all of her matches. Okay. So now we know. We know that they won 4 matches. Total, they won 4 matches. Now you want to find the probability that Claire won all of her matches, which means Claire won 3 matches. Now that's possible if we take this route. Claire won all the 3 matches. Yeah. Yeah. So probability that Claire won all the 3 matches, given that the total score was 4, that totally they won more than 4 matches. Okay. Now will be the sum of these two possibilities divided by 0.4125. Correct? So let me say A is the event, Claire all her matches. And B is the event, more than 4 matches won. Total matches won. They won more than 4 total matches. We have to find the probability that Claire won all her matches. We want to find the probability that Claire won all her matches, given that they won a total of 4 matches. Okay. Now, see, now the possibility when we look at the decision tree, okay, we know that I'll just I think I'll draw the tree once again. Claire won 2 matches. Sorry, Tom won 2 or 3. Claire won all her matches. 2 or 3. 2 or 3. Okay. So we will take this option and this option. Okay. These are the only two possibilities. The total, okay, we found this is not acceptable. The total we found here was 0.4125. 0.4125. The sum of these two possibilities is 0.2 plus 0.125, 0.3125. So 0.3125, okay, over 0.4125. Correct? I think it's become a mess. Okay, Tom won. How will they win 4 matches? Tom wins 2 or 3. Claire wins 2 or 3. We want more than 4. So this we won't consider. This, Tom can win 2 and Claire can win 3. So that will be 0.4 into 0.5. Okay. 0.4 into 0.5. That is 0.3. Tom can win 3 and Claire can win 2. So that's 0.25 into 0.35, that's 0.0875. And Tom can win 3 and Claire can win 3. Okay, it's 0.125. So we found that the probability that they win more than 4 matches together is 0.4125. Now, we know that this event has taken place. Okay, we know that they've won more than 4 matches. What is the probability that Claire won all her matches? But that's possible only if we take this option, like this 0.2, I'm sorry. Zero point 0.2. Now, given that they have won all the 4, they have won more than 4 matches, what is the probability that Claire won all her matches? Which means Claire won 3 matches. That's only possible here and here. Okay, so we will take these two into account. 0.2, either this or this. So it is 0.2 plus 0.125. Okay, that is 0.2 plus 0.125 over 0.4125. That is uh, 0.2 plus 0.125 divided by 0.4125 or 0.7878. This is 0.2. This is 0.7878. So the probability that Claire won all her matches, given that uh, they won a total of more than 4 matches, the probability is 0.7878. This is equal to 0.788 to 3 significant figures. Okay, so I think we will stop here. Thank you very much.